My name is Rowan Feely from Maynooth University, and I am the lead researcher on the EPA-funded project SoMoSAT, which stands for Soil Moisture Estimates from Satellite-Based Earth Observations. So what was the key challenge that this research addressed? Well, soil moisture is classified as an essential climate variable, or ECV. That is, it is recognized as an essential variable for use in a wide range of applications, including groundwater resource estimation, catchment and flood management, habitat mapping, crop production, and climate modeling. Yet, in spite of its importance, direct observations of soil moisture are very limited globally, and those that do exist are typically of limited duration or spatial extent. Consequently, alternative approaches for estimating soil moisture have been developed, including the use of water balance models, the use of remotely sensed information, so for example from the European Space Agency, or the application of land surface modeling techniques. While these spaceborne methods and land surface modeling approaches offer a significant potential for monitoring and modeling soil moisture at national and subnational scales, currently their resolution is in the order of tens of kilometers and typically is a little coarse. So what were the policy or societal implications of this research? Well, it is intended that outputs from this research will inform the strategic development of a national soil monitoring programme, and the soil moisture product will also support and underpin applications in a range of areas, including catchment management and sustainable land use management. More broadly, the research will support and assist Ireland in meeting its international reporting obligations and support the development and implementation of other national policies in line with, for example, the EU Water Framework Directive or the Nitrates Directive. What was the unique approach we employed in this research? So for this research, we developed a statistical machine learning based model to combine and downscale a number of data sets to estimate soil moisture. These data sets currently exist at a variety of scales. So for example, we can obtain satellite data, which is at a 25-kilometer resolution. We might have topography or elevation at a 25-meter resolution, and normalized difference vegetation index, NDVI, might be at 500-meter resolution. So we incorporated a range of different data sets, which we refer to as static, i.e. they don't change over time, such as elevation, and dynamic data sets that change over time. So for example, rainfall data sets, temperature data sets, and so forth. We developed the model on the basis of these predictor variables, but we developed the model on the basis of the in situ soil moisture network from the UK. And this was justified largely on the basis that the fact that the UK is geographically very similar to Ireland in terms of climate, soil types, land cover, and management practices. The advantage of building the model on the UK was that the UK had an existing and extensive soil moisture network, which we do not have here. Having developed the model on the UK network, we then obtained a similar suite of predictors for Ireland, and were able to predict high-resolution soil moisture estimates for across Ireland. In terms of the recommendations from the research, I think critically we need to develop a suitable soil moisture monitoring network across the island that can support direct measurement and monitoring of soil moisture conditions in real time. Such a network would also support the continued refinement and improvement of our model-based approaches. And this is important because we can't measure every part of the landscape. And models, if we can improve these models, allow us to predict for those locations that we don't take measurements. So to find out more about our project and its findings, please visit our website at somosat.com or read the research report available on the EPA's research publication website.